Okay, so this is just going to be a quick video going over the general layout for project 3, what you need to take into consideration, and then an updated method that gets used more widely in the industry. So in front of me, I have got the ERD that I used last year. We will be looking at the code in a bit. I just wanted to make sure we just get the layout ahead of time in place. So the only connection with the outside DB is going to be our DB context. Whereas in a project 2, you guys would have worked with the DB context directly. Here we have some extra obfuscation that allows us, in theory, to be able to cross-connect items to different views. How we do this is we have a generic repository that interfaces with the DB context, which from we are able to pull out our different models repositories. The way we do this is our simplest route. This generic repository only allows us to add, delete, and insert. And we feed it the type of model we are going to be using. Then we take it one step further in our model repositories and we add information specific to it. So in general terms, this is the same as what you would have done with nested classes, where you would have a student class and the student class would form part of a bigger class, for example, the school class, where these are just pulling more specific items from these. We further obfuscate it then by adding a service layer, and this is seen as the intermediary between our let's say category, for example, our category repository and our category controller. Which makes the service class so powerful is the fact that we are able to take multiple services and pull them into a single controller by doing obfuscation so that we do not need to redo the same code twice. We essentially just pull it in when needed. Now, it doesn't matter this part. From your controller down to your repository will stay the same regardless of the layout. In more industrial level systems, we generally don't use the DB context as you need to have a high understanding of LinQ, which is the language being used within it, the model.select all, that type of code. I will show you guys the difference now. Generally, we tend to go towards Dapper because it allows us to use normal SQL to interface. Plus, the DB context in 90% of cases only works well when you use it with Microsoft SQL servers. If you start looking at different servers such as distributed servers like Mongo or MySQL type servers like MySQL and MariaDB and Postgres is also a really good example, then it does not really work to use LinQ. It's extremely complicated. So for straight up MS SQL servers, this is the way you want to go. It just, in industry, you either use it entirely or you don't use Microsoft SQL servers at all. It just depends on where you end up. Yeah, once you get past the controller level, you into your views, which is where the data is actually presented. In this example, we have two different DB contexts. We have the one that's talking to our main data server, and then we have the application DB context, which is only used for the login information, and I believe I had authentication also set up on this program. So this gives you a really good overview of what's actually happening in the back end. I'm just going to quickly pause here for a second just so everybody can have a look at it properly, and then we can move on to the actual code, show the implementation. So we start off with our layout. I'm quickly going to bring my folder back. So I want to show you guys the structure, as I believe this is extremely important. As you can see here, we have one solution with 3 different projects. Again, we tend to segregate the code because it allows you to take a single entity out of this program and use it within another solution. So we have a data project, which includes our DB context, the models connected to it, and our repositories. So as can be seen in this picture, we have one solution with 3 projects within it. So the first project is our data project, where all our low-level code is. Then we have our service project, and finally our upper-level project where we have our visual code and our controllers. So if we go back a level and we go to a service layer, here we only have our services. So we're going to have our category, device, and zone, and every one of the interface classes. You need to remember that you can't directly talk to one of your classes. You need an interface class in front of it. That's very important. And then finally, we have our project in itself. The only model being stored here is the error view model, which is a generic model being used within the solution. We don't need to change it, therefore we just left it there. Same with the application DB. It functions where it is. There was no need to pull it out, as whenever you're going to create an MVC application, these get automatically generated. Uh, we had a few questions the last time. W3 root is the folder that stores, and this is extremely important as it pulls over from MVC applications to Blazor applications. This stays exactly the same. Your JavaScript is JavaScript root codes that you can run within views. So this becomes extremely important if you are doing custom components, consoles, anything of decently custom on your views gets stored here. It's where the application knows to find it. Your .css is generally your view packages, so how your buttons look, the pretty things get stored here. This application does not have any nice CSS installed, but I do believe my Blazor application that's built on the same framework does. So I'll just show you guys that in a bit. You also store your images here, as it's an easy way to get it found. And then lastly, the favicon. This I haven't seen spoken about a lot. Your favicon is that little icon in the top of your browser that, if you look at the W3 root icon, in your browser, it's exactly the same. That's what your favicon is. It's just the little icon that appears up there. It also is a .ico, so don't try just put in a JPEG, it will not work. A .ico generally is a 32 by 32-bit image. Yeah, 32 by 32 pixel image that gets created offhand. I don't think I have anything installed that could open it. Okay, one big difference between .NET 3 and .NET 6 that you guys probably noticed by now is the difference that we have a program.cs and a startup.cs. This generally does not translate over to .NET 6. It was one of the major changes. be aware that that will be different for you guys this year. Views are your actual web pages. We will go through the things that you need to know here, but this generally doesn't tend to change for what you guys are going to be doing this year. You guys are still going to need a create, delete, details, edit, and index page. Index is kind of like a home page for that specific model. So it shows all your information. Properties, you guys don't really need to worry about unless you're doing in-depth coding. This is normally where your service dependencies lie. So if you are using external packages like Dev Express, or I think Panda is also a really good one, this is generally where you would find it, but it doesn't get pulled over into MVC all that often. We went through those. Controllers are the layer just under your views. Normally you would just have one per view class. So one for the entire zone model class, one for home, device, category. It's a pretty simple thing to grasp. Areas, identities. Oh, areas is just connected to the how do I word this? The code we use to do verification, authorization, and authentication, essentially. And then if you ever go into industry and you need to publish your thing to a ISS server, you would find it within your .NET application output. So yeah, let's open up and have a look. Okay, so I'm going to first start with the generic repository. I'm not going to go into that much depth. You guys can do your own research. So let's start here. Okay, so this language being used here, the dot property as column type, all this is called linQ. It's not C, it's a variant of C sharp, but we call it linQ in the industry. If you want to go do more research, just know that this is what it's called. Same with this. These statements are called linQ. So we just have our DB context, which is just a general rundown of this is the model, and the model consists of these columns. Every column is called a property. And this last statement is just your foreign key loading. So it just says you will have one category for many devices. It has a foreign key and you give the foreign key. These are, the rest of it is pretty simple. We've just got 4 columns. This column is our ID, and we know that that value is never generated. You can go into this in a bit more detail, but it essentially just describes how the database looks in terms of linQ code with our 3 models. Directly in front of our DB context sits our generic repository. Now, the way a generic repository works is essentially in the name. We have add, get all, remove, and update. The way these work are you add any entity of type T. Type T is just a placeholder, so it could be T get swapped out for either category, device, or zone. And because you're not returning anything for addition, it's just a void. IEnumerable is pretty much standard. The only place you would not use IEnumerable is if we ran into this issue a few times where the data that you're pulling back is in the wrong layout. IEnumerable is essentially just an enumerator. So if the data you are pulling back is not in an enumerator form, you would use a list. This does happen quite a lot. You need to be able to know when to use either one. Majority of the time, if you're just going straight len queue, you don't have to worry about it. You'll always be able to return it. So we have our basics: add, get all, remove, update. These just do basic I update and I save. One layer in front of that would just then be your interface. And this is how the next layer communicates with it. It just sees these functions and it calls it. I'm not going to go through all the repositories, but I'll just pick one. So let's go with device. So the device repository is of type generic repository, and the way it would work is, let's say I wanted to add a device, we would call the add entity, and we are feeding it a type T, which in this case would be a device. Same with the get all devices. We just have a bit more control here. So like this one, for example, here you can see we use the get all twice. The first one just returns get all devices, which is just get all dot to list. We return it, we're good to go. The second one is get device by ID. Here we ask it specifically for that GUID. So we say get all, and then we use first or default, where X, and then we initialize X, and we say where X dot device ID is equal to that ID that we just pulled in. Remove device and update device, same as the add, we are just feeding it an entity of type device, and then we feed it through to the generic repository. The I interface class for the iDevice repository is, again, we're just pulling the functions out. Once we have that, we can go one layer up to our device service, which is a service class. And as you can see, when we initialize it, we initialize it with the device repository. Here you can see we have a bit more again of updates. So we further break down our device repository to get individual items. Nothing really all that complex in the system at the moment. And then in front of it, we again have our service class. The reason for all this breaking up from the DB context to the controller is the ability, again, so that we can pull in multiple items into a single controller. It's extremely important. You guys need to be aware that this is the correct way to do it. Going directly from your DB context, if you initialized your DB context for your device controller, it's only meant for that one. You can't reinitialize it for, let's say you wanted to pull in device, zone, and category. You would have a hard time doing it directly from your DB context because you can only initialize it once. It's possible, but it's not the correct way to do it. Then we move up to our controller level. And as you can see here, this is what makes it so important. We initialized our device controller with device, zone, and category straight out of the box. This is great because, as you can see, we can pull view data, which becomes extremely important when we start having views that pull from all three. We can say, okay, these two get pulled, and then we return everything together. Details, same thing. We're returning a lot, 3 different services into a single view. And this is the controller is your place where it would happen. A few things of note is if you have authorization involved, you need the authorization token at the top. You don't add it, it doesn't matter if you did all the background code. Sorry. Your controller is still open to the world. There was one other thing I had to do. Oh, the validate anti-forgery token. So in this instance, it doesn't play all that much of a role, but This is just to give you a way to stop spoofing through the website. It's a bit hard to explain, and I think it's not something you really need to know about right now. But the way it works is, let's say we have our inputs, which we are binding to this entity. If you were to put in items through the inspect menu, for example, and then click the button, it would make sure that it takes the values that are in the input boxes. It would not take the values that you put in through the inspect menu. Not really something you have to worry about, but just note that this is an important. And if you're going into jobs where security is high risk, this would be something you see a lot. Then we just have the basics, same as your API, where you've got the index, the details, you can create, edit. I've got 2 edits here, they do different things. How it works is you have, let me find a good way to do this. Okay, so the one edit takes you to the edit page, and the second edit, bad on my part for not naming them correctly, but the second edit actually edits the data. Both pages pull from the same controller, so that's why it is needed. Yeah, I think from this level up, we start looking at, okay, so the home page, just your index page. This code is, okay, so this down here is HTML, but this at the top is C#. You can know the difference by just looking for the @ symbols. And how we tell each page is by looking at the view data. This comes into play when you start looking at your shared pages that are generally in charge of your menus and things. So in MVC, they do it differently from Blazor, where you would have where you would speak to the controller, and the controller would tell you which page to go to. So for zones, you would go to the zone index page. Categories, the index categories page. You would do that. Special code here, and this will probably be given to you, as I'm not sure how the thing is laid out this year, is we are, just change that back. I specifically have this stuff behind an identity tag where we check first if the user is authenticated. If they are not, we don't display this stuff. We only display the login and the register. Once they're logged in and they're authenticated, we can display something else. So it's kind of an if within a view statement, so it changes the way things look. If we look at our device edit, we'll look at those now. So as you can see up here, this is where we pull our model in. So our model just gets pulled in as IEnumerable, and then we actually display our data. Nice thing about this is this model over here automatically talks to your controller. You don't need any other code. It's a bit simpler, but it loses power at the same time. I don't think I have this database up and running anymore. We can try it just now, but I doubt it. So this would just be a basic view with, we've got a table, and then within the table, we've got 1, 2, 3, 4, 5 columns, and it would just loop through all the items within the model and add them. And then the last 3 columns over here is just the edit details delete button that would then take you to a ASP root. to the device ID. And the way it works is, for example, let's go to the edit page. If I click the edit button, it says, okay, I'm routing to the edit page, but using this device ID. So this is how I move data between the table views. I feed the device ID through. So if I go to the edit page and you come to the bottom, where did I have it? Okay, this is sorry, I haven't looked at this code in almost a year at this point. This is going to be an input form. Just by the way we've set it up, it's a form, ASP.NET action edit. Scripts away. Okay, so how it knows where it is on the edit page, if we could go back, is we're going to the edit action, which is the edit page, the view, and we are using the root ID, which is item.device ID. That gets fed through automatically, so when this page generates, it automatically generates with that ID. And then it's essentially as if we are working with a variable where we initialize the variable and now we're viewing it. So things like the device name, model, all that thing's already in place. Same with the index page. No, not the index page, the details page. You see, we already have the model existing within the page, which makes the coding a little easier. It's just an assume for that it already exists. And then we just grab each item one by one. I just want to quickly check if I run it, what happens. I doubt it's going to build. So I don't think that connection exists anymore. Yeah. Let's check. Okay, it's pulling from my thing. Oh, yeah, this one does not have a JSON file because it's my GitHub copy. Yeah, it's not gonna run. But actually something else I wanted to show you guys. Just want to quickly find out where it would have stored. Just wait for it to finish breaking. Broken. Sorry about that. Okay, so we didn't add it here. This is the old way of doing it in .NET 3.1. This is how you would have added an identity. So there was two different ways of doing it. Either you would have, and it still persists, we use it in Blazor, where you could either use the Microsoft authentication framework, which takes a lot of the security and worry out of your hands, where you would use your Microsoft account to sign in, and that would be directly linked to a tenant. Tenant is just a fancy way of saying the company, so that anyone within the company who is part of a specific group would be able to access this application or sign into it. The rest of the people or someone externally trying to sign in would just get an error page saying they are not allowed to. So this is how we added identity back then. As you can see here, I have two DB contexts. Both of them were built into the same database. Normally they're different databases just for segregation of your data. And then lastly, you would just add use authentication and authorization to your application. So it knew it had to use your identities. The startup was kind of where all your code was hidden, laying. And then, yeah, MVC uses Razor Pages, which is wrongly named, but you kind of get to know the differences once you work with something like Blazor. I think I'm just quickly going to show you guys the Blazor one as well, just to show you what Dapper looks like. As I think it's of note and definitely also a viable route. If you do not want to use a DB context and you want to directly interface with the DB, this is also one way to do it. You will still be using the entity framework core, but you're just using it a bit differently. So the way it works, and it's a bit simpler in the fact that you could always break it up into two different. Generally, we have a data access library, which is a solution on its own, wherein your services, your models, and your data lie, but your data is a lot more simple. You just have a SQL data access. The way it works is it's a mixture of your, okay, it's going to error out because I don't have the packages installed anymore, but it's a mixture of your DB context and your generic interface, your generic layer. So essentially you would be putting these two together into a SQL layer. That what makes this powerful is the fact that it allows you to use any DB, as I said, or any architecture for that matter. So we would be using Dapper and the SQL client in this example, where you have a few different things. You load entire list of data, or you load a single. As you can see here, when we're talking about a SQL style of connection, we have a task of type list, and it's again a generic class. The second parameter is just the parameters you're feeding through. I'll show you guys the difference now. But then, yeah, you load the data, single, and you have a delete and a save. Your save takes the place of your update and your add. It's one statement that does both. And as you can see, essentially what we're doing is we're executing a SQL statement. We feed it the SQL and the parameter. If we go to our service layer for the device data, you can see it pulls in the SQL data access layer. And then instead of LintQ, we just use normal SQL. So if we want to get our devices, we just say select all from DBO device. We call the load data function. We feed it the device. And then the second part, our second variable of type U is dynamic because we're giving it the SQL with no parameters. If you had parameters like this, let's say we're trying to get the device by its ID, our device is a GUID, so we need to go create a parameter. So what we do is we say, okay, we need a new parameter called device ID. And then in our SQL statement, we say select all from device where device ID equals at device ID. And this second one gets fed to this one. They interact with each other because it's the same name and at says it's parameter. And as you can see with this one, now we're doing a load single, again dynamic, but instead of no parameters like this one, we're saying, okay, we're feeding you the SQL with parameters. And then, yeah, the insert, basic insert. The only different issue with this one is the fact that you have to write out your SQL statements. But in larger applications where you have extremely complex SQL, this is still the best way to do it. It's a lot faster than LintQ. Guys just tend to prefer it because of the fact that it runs faster. It might be a bit more complex on the back end, but it's better. Gives you a lot more control. So you've got your insert statement, your update statement. Now, have a look at these. We didn't give it a parameter, but a model. So we said insert this, and then we gave it all the values of the model that are present. This would have failed anyway because we're shorting a comma. And then we said go save that data, and here's the model, and within the model you will find each of these. Now these directly correspond to, if we look at our model, what is this device? The spelling here is exactly the same as the spelling here. That's what makes it so important. Same with the update, just a simple update statement. And then the delete, again, we're not going to give it the entire model. Instead, we just give it the ID of the model, feed it through as a parameter. Apart from that, this is a Blazor application, so the layout's a bit different. We have an app.razor and a program settings. We also don't have controllers. Everything is baked into your pages. Your page becomes a lot more powerful. You guys don't really need to see this, but I'll add it in a just an extra bit of detail. So the way it would work is you feed through your services directly. So in this place, we called our services device data. So we get it through. The navigation manager is how you get it. The page layout is also a bit nicer because of the fact that you put your GUID, your IDs to access anything within the page layout, giving you a bit more control. Here we just have a load page and then a simple bit. And down here is your code that actually goes and fetches your devices. And then again, use your click edit, your click list. And from this information, it just takes it and puts it in over here. So we're calling our device, which is this variable, and we're filling in all the information. It's a lot nicer, but you guys will get exposure to it once you hit industry. Also, you wouldn't use it directly like this. You would normally use it through DevExpress or some sort of other front-end package. Also, your program.cs is a lot closer to what you guys are currently used to. One thing of note, and I'm not sure if this is applicable to .NET 6 MVC, is you have transients. So your transients are all these services that we have, our repository classes. All of these need to be brought in. You need to tell the program they actually exist. And then, yes, your authentication gets done a bit differently, but you still bring in the authentication authorization. Yeah, I think that's pretty much it. Let me think. Okay, yeah, I think we went through all the different types. Connected office context is just where your database model lies. Views and your things. No, I think this is pretty good. If you have any questions, yeah, you could send me a message, but don't expect a fast reply. I am busy during the day. But yeah, thanks for watching.